Hello and welcome to Science. Today we're going to be doing about ammonia and fertilizers, and that's going to help you fill in the 15A pack. Ammonia is a really useful chemical. As you can see from this diagram, it has a central nitrogen atom surrounded by 3 hydrogen atoms which are all covalently bonded to the nitrogen atom. It's a basic molecule, so it will react with acids and neutralize them. And also, due to its lone pair of electrons here, can form some hydrogen bonds as well, although quite weak ones. It's a very useful molecule because it's a good source of nitrogen for plants. Now, plants need nitrogen to grow, and it's a main component. One of the biggest uses of ammonia, about 75 to 85% of the production of ammonia goes into making fertilizers. The common fertilizers you'll need for the exam are the NPK fertilizers. So nitrogen is the N, phosphorus is the P, and potassium is the K. These are building blocks that help make the plants grow and increase yields. The source of nitrogen is usually in the ammonium salt. So that's ammonia with an extra H, making it NH4+. The phosphate produces the phosphorus, and the potassium salt is from potassium nitrate. The most important of all these in terms of plant growth is the nitrogen, and so you'll notice that each of them do have some nitrogen in to increase the amount of nitrogen. You can't just use nitrogen gas because the plants can't take that up. It has to be a soluble salt, which is why we put them into these forms. To make these fertilizers in the laboratory, you'll use a neutralization reaction. So the basic ammonia is reacted with an acid to form the ammonium salt. You can see the reactions for each one here, both the word and the balance symbol equations. To actually do these, you'll need to do a titration to work out the amount of acid to add to completely neutralize the ammonia. And once you know that amount, you can then repeat the titration without the indicator to make the salt. You will then be able to evaporate off the water to collect the pure salt. It's obviously really important to be incredibly accurate with that, because if you are using it as a fertilizer, you don't want to be changing the pH too much of the soil that you're putting it on. If you use too much acid, then it'll lower the pH. If you use too much ammonia, it'll raise the pH. Industrially, ammonium nitrate is made in a slightly different way. Rather than just starting off with the ammonia, we make the ammonia and then we also make the nitric acid from the ammonia. So the first step is to make the ammonia, and we're going to do this in a bit more detail. We have the nitrogen gas reacting with the hydrogen gas reversibly to make ammonia. We then use some of that ammonia to react it with oxygen to make nitric acid and water. That's the overall equation. It takes several steps to make that. We can then react the rest of the ammonia with that nitric acid in a neutralization reaction to make ammonium nitrate. Ammonium sulfate is made industrially through this what looks like quite complex process. In actual fact, you only need 4 ingredients to make ammonium sulfate. You need some sulfur, air, which contains 2 of the components that we need, the nitrogen and the oxygen, water, which is in plentiful supply, and methane, which is natural gas. The first step is to make some sulfuric acid. So the sulfur is burnt in air to make sulfur trioxide. This is a multi-step process, but overall, that's what's happened. That sulfur trioxide here is then reacted with water to make sulfuric acid. To make ammonia, exactly the same as before, we need nitrogen and hydrogen. The hydrogen comes from a methane reacting with water to get some hydrogen, and the nitrogen comes from the air. They're combined in something called the Haber process that we're going to have a look at later, and that is the reversible reaction we saw in the previous slide. That makes ammonia. Once you have your ammonia and your sulfuric acid, you can react them together in the correct quantities to make ammonium sulfate. The advantages of this process over doing it just in a laboratory is the fact that this can be a continuous process. So you keep on making sulfuric acid, you keep on making ammonia, the two react together. You don't have to stop making it. Whereas in a laboratory, when you're doing a titration, you make a batch of it. So it's a batch process, you don't make as much of it. Obviously, it's much harder to do this, and you need very complex, expensive machinery. So it needs to make it's worthwhile. So a common exam question might be something like, explain how nitrogenous fertilizers are made in the laboratory. 4 marks. Because it's an explanation question, you're going to have to go into detail of how it works, and the 4 marks says there's quite a lot you need to be able to do for it. So firstly, you need to be talking about what the nitrogenous part of the fertilizer is. So a good thing to go for there is to say that it's going to be an ammonium salt. Then the other part of it, you might want to be having a look at either a phosphate or a nitrate or a sulfate. You can then explain how you make that, so to do a titration between ammonia and the chosen acid. Firstly, with indicator to know the exact end point of the reaction. Then secondly, without indicator, to be able to do the reaction to get the pure salt. Because both the acid and the ammonia will be aqueous, you need to get rid of the water in the reaction. Now you can show this as well with balanced symbol equations. To get rid of the water, you'll need to heat to dryness, evaporate to collect the salt. Giving a couple of examples of different types of fertilizer made will make sure you get all the marks for that. Cheers.